Um, I think this is the easiest lesson that we have in this set of lessons. Some kids, it takes a little bit of time for it to click. So I'm going to try to go slow. And if it still doesn't click, just let me know. Okay, I should have set this to like pop up one topic at a time as I talked about it, but it's already here, so I don't want to redo this. So here's the thing. There are going to be times that radicals cannot be solved, right? We talked about that last video. Square root of 4, the answer is 2. Square root of 4d is not a whole number. This lesson is talking about simplifying those radicals, and they're pretty simple. Now, some books teach you that you have to break this down into its factors that are square rootable, which is fine and makes sense, except that what I have found is it often takes students longer time to find those, so I do mine slightly differently. So what we're going to do first is we're going to break our number, the number under the radical sign, into its prime factors. And you can look at this example. 12, if I tree 12, I sort of just did it, I get 4 and 3. 4 is 2 and 2. So broken down into prime factors, it's 2 times 2 times 3. Now we're going to pull out any pair. So here's the thing. If I have square root of 2 times the square root of 2, what I get is the square root of 4, which is 2. So any pair of radicals pulls out as one whole. Any pair of factors pulls out as a whole. So if I have the square root of 5 times the square root of 5, that is technically the square root of 25, which is 5. The pair pulled out as one whole. And then we're going to simplify now. Right now, the simplification is just pulling it out. So square root of 2 times the square root of 2, the pair pulls out as 1. The leftovers stay put. So we're going to break it into its prime factors just by treeing it. And then we're going to pull out any pairs of factors. A pair of numbers pulls out as a whole. Leave the leftovers. Let's look at a couple of examples. This first one is square root of 18. So step 1, break into its prime factors. I'm going to do 9 times 2. You can do 6 times 3. You'll get the same place. 9 is 3 times 3. So the square root of 18 is equal to the square root of 2 times 3 times 3. Now that is the same thing as this. I just don't like having to write that radical sign over and over, so I put it all under 1. And remember, a pair of radicals pulls out as 1. So this becomes 3, and the leftovers stay square root of 2. Tree it, pair it, match it up, or pull it out. Now, square root of 10. Now, pay attention because this is a whole number. It is not under the radical sign, which means it does not get treed. It just stays. This 10 just stays put. I'm going to break up my 125. So sorry, I sneezed in my microphone. All right, so 125 breaks up. It ends in a 5, so I know I can divide it by 5. And I have 5 times 25. 25 is 5 times 5. So what this becomes is 10. That whole number just stays put. 5 times 5 times 5. Let's treat it. Now I'm going to pair it up. I have a pair of 5s. Well, that pair of 5s is going to pull out. When I pull it out in front, I'm going to multiply. That last step that says to simplify, this is what it means. So I'm going to pull that 5 out, and when I do so, I'm going to multiply. My leftovers stay put. 10 times 5 is 50. The square root of 5 cannot get any simpler. So it just stays just like that. Tree it, pair it, simplify it. You already know what I'm going to say, so just pause it, try them, and then come back and check. All right, let's do these. Okay, I'm going to kind of work them fast because you've already done them, right? So if I tree 24, what I end up with is 2, 2, 2, 3. I think I did that in my head. Let me check. Yes. Okay, now I'm going to pull out. I'm going to pair up anything. That pair is going to pull out in front as 1. And just like when I had 2 things out front, if I have 2 things inside, I multiply them. So my reduced or fully reduced answer is 2 square root of 6. Okay, number 2, we have 50, or square root of 50. 50 is going to break down as 2 and 25, which is 2. Oh goodness, that's a terrible 5. Times 5 times 5. I'm going to find my pairs. That pair is going to pull out in front as 1. And my leftovers stay put. So what I have is 5 square root of 2. All right, number 3. When 28 breaks up, I end up with my 3 stays put. On the inside, I'm going to have 2 and 14, which is 2 times 2 times 7. Let me check that. 2 times 2 times 7. Yep. I'm going to find any pairs. It's going to pull out in front. So what I have is 3. And remember, if I have more than one thing, it becomes multiplication, which gives me 6 square root of 7. Now let's look at our last one. We have 3 square root of 200. Now 200 is going to be, oh, my pen. 2 times 100. 100 is 2 times 50. 50 is 2 times 25. 25 is 5 times 5. Now let me just check that. 2 times 2 times 2 times 5 times 5. 200, perfect. Find any pairs. I have a pair of 2s and a pair of 5s. Both of those are going to pull out front. I'm going to have my original 3, pull out my 2, pull out my 5, my leftover 2 stays put, and remember, I multiply. 3 times 2 times 5 is 30. So what I end up with is, I lost my train of thought, I'm so sorry, 30 square root of 2. And that's as simple as that gets. And that's it for this lesson. So just remember, when we need to simplify, tree them out, pair them up, and then simplify. But when you have a pair, it pulls out as 1.